To show that the derivative of cosecant of x is equal to negative cosecant of x times cotangent of x, we first start by writing f of x equals cosecant of x. But we know that cosecant of x is 1 over sine of x using a basic trig identity, really the definition of what we have for cosecant of x. And so now that we have rewritten it this way, if we use the fact that the derivative of sine of x is cosine of x and the quotient rule, we'll be able to come up with what the derivative is here and complete the proof. Now this proof is extremely computational. It really just involves a quotient rule, a known derivative, and a couple of basic trig identities. And so we take the derivative here. Knowing that it's a quotient rule, I go ahead and I write the denominator as sine of x squared, because that would be the denominator on the other one. And we've got to finish up this quotient rule. So we've got the derivative of the top. So we've got the derivative of the top is the derivative of 1 times the bottom. So that would be times sine of x minus the top, which is 1, times the derivative of the bottom. And that's where we're going to utilize that fact. Whoops. The derivative of sine of x. And in the next step, we'll go ahead and compute it. All right, so we've got so far cleaning this up. I'm going to keep writing the sine of x quantity squared there on the bottom. And we know that the derivative of 1 is 0 because the derivative of any constant is 0. So we're looking at 0 times sine of x minus that 1 times the derivative of sine of x. So that would be minus the 1 times cosine of x. Okay, so continuing on here, we know 0 times sine of x would simply be the 0. So we're looking really at just negative cosine of x on the top and sine of x squared on the bottom. Now this is where we kind of have to start playing match the other side of the equation. We want to show that the derivative of cosecant of x is negative cosecant of x cotangent of x, so we've got to be able to group what we have strategically so that we can arrive at that answer. So we do have that negative that's out front, so that's good. We're just going to bring it out front instead of put it at the top. So if we're trying to play match cosecant of x, we know ahead of time that cosecant of x is 1 over sine of x, and that works nicely because, see, we can just take that cosine of x that's squared in the bottom, sine of x that's squared in the bottom, and we could put one copy of it under one fraction and one copy of it under the next fraction that's multiplied. It's just taking two things that are multiplied and splitting it up. So now if we're looking here, cosecant of x would just be the 1 over sine of x, and that's good because we really only have one copy of cosine of x on the top, and it needs to go over here. And it goes over there to be able to then fully complete the cotangent of x as cosine of x over sine of x. And so with our very last trig identity, or two trig identities, we can just now write this as negative cosecant of x times cotangent of x, where we've already got the negative out front too. And so that completes our proof. Very computational proof that we have full confidence you guys can handle.